And then we'll be talking about the genetic functions from very basics to very advanced, and try to solve some like previous year gate and some gate questions also. So let's start with pigeonhole principle. So this is the agenda which is written on the board. So let's start the pigeonhole principle from very scratch. Okay. So pigeonhole principle. First of all, what is the pigeonhole principle? Let's try to understand from very like a bird's view. Suppose, let's say that we are going to have A is the, let's say the average number of, let's say A is the average number of pigeons. Let's say A is the average number of pigeons. And then definitely I'm saying what, let's say A is an average number of pigeons in a pigeonhole. Let's say A is an average number of pigeons in a pigeonhole, then I'm writing one statement and then I'll explain that statement with the help of an example, right? So I'm saying one statement, that is, if A is the average number of pigeons in a pigeonhole, then some pigeonhole contains at least seal value, this is seal value, at least seal value number of pigeons, and some pigeonhole contain at most lower value number of pigeons. Now what is this statement saying? Let's understand with the help of some example. Let's say, suppose, let's say we are going to have 10 pigeons, and let's say we're going to have 4 pigeonholes. Let's say we have 10 pigeons and 4 pigeonholes. Let's draw it and try to like understand from like very basic. Suppose we are going to have 4 pigeonholes is going to be there. Let's say these are the 4 pigeonholes. If I'm having 10 pigeons, let's say I'm putting 1 here, 1 here, 1 here, 1 here. Then 6 is remaining. So let's say I'm putting one more. Then I think 8 is covered, 2 is left. 2 is left. Then 2 can put up in any of these. Let's say I'm putting in this and I'm putting in this. So I'm seeing here that every pigeonhole will have at least how much? At least two will be there, and at most how much? At most 3 will be there. Are you getting my point? So definitely some pigeonholes will be consisting of 2, and maximum it can contain is 3. Right, so this is the like very basic if I thought of. Now let's put up all of these things in terms of this formula. So if I see like this way, so if A is the average number of pigeons, let's find the average. Average is nothing but 10 by 4, which is I think 2.5. Then I'm saying some pigeonhole will be consisting of at least 2.5 seal value, which is nothing but 3, right? And it is consisting of at most how much? At most it is consisting of like lower value, which is nothing but 2. So you can see it will be consisting of minimum 2 and maximum rate will be consisting of 3, right? So this is the basic funda that we are going to understand. Now let's move forward. Now I'm writing one more statement. Let's say that if I'm writing one statement more, let's say I'm writing if n plus 1 pigeons are there and n pigeonholes are there, then definitely if I find the average would be nothing but what? N plus 1 by n. So I can write it as, if I just divide it, it would be 1 plus 1 by n. I can write that as like this way. So if I find some will be consisting of at least how much? Some would be consisting of at least 1 plus 1 by n seal value, which is 1 plus something, seal value is nothing but 2. And it can consist of at most how much? It will be consisting of at most 1 plus 1 by n lower value, which is nothing but how much? It will be 1 pigeon. So this is the one funda that we are having. that if we are having n plus 1 number of pigeons and n pigeonholes are there, then the average would be n plus 1 by n, and then it will be consisting of at least 2 pigeons minimum, and at most it will be consisting of 1 pigeonhole. So this is the basic like we are understanding. Okay. Okay. So let's move forward. Now let's try to extend this concept to some another thing and understand with the help of this. Let's say now we are having 2n plus 1 number of pigeons and n pigeonholes are there. Then again the same thing. Average would be nothing but sum of all the pigeons divided by the total number of pigeonholes. Then it would be nothing but how much? 2n plus 1 divided by n. Then the average would be nothing but how much? 2 plus 1 by n. Right? So average would be 2 plus 1 by n. Then again I'm repeating the same concept that some pigeonholes contains how much? Contains seal value of 2 plus 1 by n, which is equal to 3 pigeons. And again, I'm writing the same thing that some pigeonholes contains this is at least and this is at most. So some will be consisting of 1 plus 2 by n, which is equal to 2 pigeons. So what I'm understanding from all of these concept is if 2n plus 1 number of pigeons are put up in n pigeonholes, then the average would be 2 plus 1 by n, then some pigeonhole will be consisting of at least 3 pigeons and some pigeonhole will be consisting of at most 2 pigeons, right? So let's generalize this whole concept, and after generalizing it, then we discuss many problems on pigeonhole principles. So let's get started. Now let's generalize it and understand with the help of a very generalized concept. Let's say that if k is a positive integer, let's say that k is a positive integer, and let's say we are going to have if kn plus 1 pigeons are there and we need to put them in, let's say, n pigeonholes, then we know what is an average. Average, everybody knows the sum of all the pigeons divided by the total number of pigeonholes. So kn plus 1 divided by n. So that would be nothing but how much? That will be k plus 1 by n. So again, we're writing the same thing. If kn plus 1 number of pigeons are put up in n pigeonholes, then average would be k plus 1 by n. Then some pigeonhole contains at least how much? Some pigeonhole will be consisting of at least seal value of k plus 1 by n, which is how much? Which is nothing but k plus 1 pigeons. And some pigeonhole contains at most lower value of the same, which is k pigeons. So if you just know this funda, you'll be able to solve every question on pigeonhole principle. So I'm repeating this whole concept again. If k is a positive integer and if k pigeons are need to put up in n pigeonholes, then average would be kn plus 1 divided by n. So it is nothing but k plus 1 by n. So some pigeonhole will be consisting of at least k plus 1 number of pigeons, and some pigeonhole will be consisting of at most k number of pigeons. If any doubt, please ask, and if it is clear, then write up in chat window. If it is clear, please write up in chat window so that I can proceed towards the questions. Yeah, thanks for the confirmation. Ajinkya, Siddharth, and Nidhi. Yeah, okay. So whatever we have discussed just now, I'm writing it in one theorem. If we just know that theorem, then we'll be able to solve any question of the pigeonhole principle. We need to understand it, mug up that theorem, then be able to solve any question on pigeonhole principle. I'm writing that theorem now. So the theorem says that suppose we have just 1 second. So suppose we are going to have n pigeonholes, then minimum number of pigeons required to ensure that some pigeonhole contains at least k plus 1 number of pigeons is equal to k into n plus 1. So I'm repeating this theorem because if you know this theorem, you'll be able to solve any question on pigeonhole principle. So it says that suppose we are having n pigeonholes, then the minimum number of pigeons required to ensure that some pigeonhole contains at least k plus 1 pigeons is equal to k into n plus 1. And we've also seen the derivation of this. We have already seen in the just like 2 minutes back. So let's solve some question over this so that this concept is very clear, right? Okay, so the first question is, what is the minimum number of persons we have to choose randomly to ensure that at least 10 persons were born in the same month. So the first question is, what is the minimum number of persons we have to choose randomly to ensure that at least 10 persons were born on the same month? If anybody wants to try, you can. Yeah, Ajinkya, you are right. Your answer is right. Yeah. So first thing is, how do I know that this is a question of pigeonhole principle? So first thing is, in pigeonhole principle, the biggest clue that we have to apply the pigeonhole principle is the word minimum. Whenever we get the word minimum, it is a very strong indication that we have to apply the pigeonhole principle. And second thing is, they are saying that we are having the same month. So it is actually saying that we are going to have 12 pigeonholes. So the first pigeonhole is, let's say, for the January month, and the second pigeonhole will be for, let's say, February, and so on. So this whole question gives us indication that we have to apply the pigeonhole principle in this question, right? So first thing is, if I apply the same theorem that we have just written, then if I see that it is saying that we have to choose at least 10 persons, and the theorem says that at least k plus 1, at least k plus 1. So in this case, k plus 1 is equal to 10. So k becomes 9. And it says that the minimum number of the pigeons we need to get at least k plus 1 pigeonhole, like pigeons in pigeonhole, would be k into n plus 1, right? So in this case, k is nothing but how much? 9. And n is nothing but the number of pigeonholes. So the number of the pigeonhole is nothing but number of months. Number of months is how much? 12. So 9 into 12 plus 1. So by solving that, we get 109. So this is a thing that we've solved just in 2 seconds with the help of the theorem that we just discussed. But if I do not remember the theorem, but is an other alternative that we also discuss it. So now apply the very basics concept. That is, first thing is, we need to find the average, right? So let's say the average is A. Then one thing I know, that average is actually given to me in the question as 10. Now we also know that average is nothing but, let's say the number of the persons we are having is X. Then the number of pigeonholes is nothing but how much? 12. So 12, right? And it is saying we need to pick up at least. At least means C value. So it is equal to 10. Now we can find such value of x in such a way that it would be equal to 10, right? So we need to find the minimum value of x in such a way that by taking the C value, it would give us the value as 10. So the minimum value would be nothing but 109 again, because 109 divided by 12 is nothing but 9 point something, which by taking the C value would give us the answer as 10. So the answer for this question is 109. If it is clear, please give the confirmation so that we can discuss the second question. Yeah, okay. Let's discuss the question number 2. Question number 2 says, a bag contains 6 red balls, 8 blue balls, 10 green balls, and 15 white balls. Question is, and 20 yellow balls also. Question is, what is the minimum number of balls? What is the minimum number of balls we have to choose randomly from the bag to ensure that we get at least 6 balls of same color. Second question says the bag contains 6 red, 8 blue balls, 10 green balls, 15 white balls, and 20 yellow balls. What is the minimum number of balls we have to choose randomly from the bag to ensure that we get at least 6 balls of the same color? Anybody can try. We just need to apply the theorem that we discussed. That's it. If he doesn't know the pigeonhole principle, this question solving, like approaching, would be quite difficult. Anybody can discuss their approach also if they want. Yeah, Ajinkya, right answer is like 26. Your answer is right. You can also tell the approach. How do you approach the question? Ajinkya, can you explain your approach to everyone? Yeah, your approach is right. So let's start with the approach now. So first thing is, again the question says we need to find the minimum number of balls. So minimum number of balls will give us a strong indication that we have to apply the pigeonhole principle. Again, I'm telling you. And the question says that we're going to have some number of red balls, some number of white balls, and some number of yellow balls. So it gives us indication that we're going to have some pigeonholes is going to be there, right? So we are going to have here how many number of pigeonholes would be there? 1, 2, 3, 4, 5. So 5 pigeonholes are there, right? So n is nothing but 5, right? So we also know, and we also discussed in the previous question, that we need to have at least 6. At least 6 means k plus 1 is equal to 6. So k directly becomes 5, right? So we discussed in the theorem that the minimum number of the minimum number of the pigeons we need to have in order to ensure that some pigeonhole would be consisting of k plus 1 would be nothing but how much? K into n plus 1, right? So we can directly apply the formula here. So k is nothing but how much? 5. So n is nothing but how much? 5. So 5 into 5 plus 1, which is how much? 26. Right? Simple, right? So let's modify this question a little bit and try to solve that question now. Now the question I'm changing a little bit. Question says, we need to have at least 9 balls of each color. 9 balls of the same color. Now the question says, we need to, like, what is the minimum number of the balls we have to choose randomly from the back to ensure that we get at least 9 balls of the same color. Only difference is now we want at least 9. At least 9 balls of the same color. Siddhant, I think your answer is not right. 16 is not the right answer. Anjali, I think your answer is also not right. Ajinkya, can you solve it and tell me how much it becomes? I think by solving your answer, I think it is 39. Yeah, 39 is the right answer. So let's try to solve from very basics and see how this question can be solved. So the first thing is they want that at least 9 balls of the same color. Means in order to find the minimum number of balls to get at least 9 balls of the same color, we are having 6 red balls and we're having 8 blue balls. If I need to find and if I need to cater 9 balls of the same color, then minimum I need to pick up 6 here and 8 here because they are less than 9. If I want that, I want, let's say I want red balls, then these all red balls I need to pick up, right? So I need to pick up all these red balls, and here from blue balls I also need to cater up all the 8 balls. Then all other quantities are actually nothing but more than 9. It means that to find a minimum, let's say I'm picking from this 10, let's say I'm picking up 8. Why I'm picking up 8? Because I need to cater up 9 balls. If I pick up 8 balls here, then my requirement is not satisfied. But I am finding the minimum, then then I will add 1 to it, so it will satisfy my requirement, right? So let's say I'm picking up from this 10 green balls, I'm picking up 8. Again from this 15 balls, I'm picking up 8. Again from this 20, I'm picking up 8. Now this will not satisfy my requirement. Why? Because I want to have at least 9, but I've picked up 8. So I will add 1 to it in order to satisfy my requirement. Why? Because this 8 can combine with this 1 to give me the requirement of 9. This can also combine with this to give me the requirement of 9 and so on. Right? Similarly, this 6 can also combine with this 1 to get 7. Now, if I get 7, then I need to pick up at least some another ball in order to cater up nothing, but the total would become actually 9. So in this way, we can solve that question. So only difference in this question and the previous question was, in this question, we need to pick up at least 9, and we are having the balls of red color which is less than 9. So it's simply a simple idea is, if you need to find up at least something and the balls we are having is less than that quantity, then you need to add up all those balls together, and then from the rest of balls we will add 1 less than that quantity, and then we add 1 to it to find the minimum number of balls, right? So let's solve this question. Let's modify this question a little bit and let's practice one more question on this. Now let's say we want to get at least, let's modify this to 12. Every question is same. Now I want at least 12 balls. At least 12 balls. Now anybody can try and tell me the approach of solving this. Only difference is now we want to have at least 12 balls. Only difference is now we want at least 12 balls here. So let's solve this question again. It is very similar to the previous question only. So now here I want 12 balls, right? So if you see here, these we are having 6 red balls, which is less than 12. Again, we are having 8 blue balls, which is less than 12, and we are having 10 green balls, which is less than 12. So first thing is I need to add all of them because they are less than 12, and I need at least 12. So I need to add up all of them. So 6 plus 8 plus 10, right? Now we are having 15 balls and I want at least 12. So let's say I'm picking up 11. 11 will not satisfy my requirement, but what I do is at later point, I will add 1 to it to satisfy my requirement, right? So we are having 15 white balls. So I'm taking up 11, which is 1 less than 12. Again, from these 20 yellow balls, I'm picking up 11. Now, this 11 will not satisfy my requirement. Why? Because I need at least 12. So to this whole, I will add plus 1. So by solving this, we are getting the answer as I think 47. So the 47 is the right answer. If any doubts, please ask. And if it is clear, please write in chat window also. If it is clear, write in chat window. Yeah, thanks for the confirmation. Let's proceed toward the next question. So you can see from this example also that this question was not difficult. This was only based upon a very fundamental concept, right? So let's discuss one more question over this. So the next question says, a CS department offer 4 years BTech program, 4 years BTech program with an intake of 60 students, with an intake of 60 students each year. A student club can be formed. A student club can be formed in the department with any 10 second year student, or any 8 third year students, or any 6th final year student. Question says, what is the minimum number of students? What is the minimum number of students to pick randomly to ensure that student club is formed? So the question says, a CS department offer a 4 years BTech program with an intake of 60 students each year. A student club can be formed in the department with any 10 second year student, any 8 third year student, or any 6 final year student. But as a minimum number of the students, we need to pick up randomly to ensure that the student club is formed. So that the student club is formed. Anybody can try it. Again, it is based upon the previous concept only, in the previous question. I think answer is quite, it is close to right, but is not right. Your approach is right, but your answer is not right. Maybe you are missing one term wrong. Again, also, your answer is actually 83, but it is 82. So, probably one thing you are missing. One thing you are missing, I guess. So, let's solve this. Again, if you see, this question is very simple. Why it is simple? Because the question says we need to pick up minimum. Because minimum word is there, it simply means we need to apply the pigeonhole principle. That's it. So we need to apply the pigeonhole principle in this question. PHP stands for pigeonhole principle, not like that preprocessor hyper processing, whatever it is, PHP, right? So how to do it, right? First thing is, again, we are having 60 students, right? So if I want to form a club, then definitely I can take up all the 60 students to form a club, one thing. And also I can do is, like, I can also pick up 10 students from first year to form the club. So let's say I'm picking up 9. 9 would not form me a club. 9 would not form me a club, because to form a club, we need to cater up how many we will need 10 students, but I'm taking 9, right? So also from the second year, I can even take 8, will take 7 students. Why? Because 7 will not form a club, then I will add 1 to it to form the minimum number of students, right? So again, from the final year students, we can pick up 5. So by adding this, it will not form me a club. Why? Because we need to get 10 first year students, but I've picked up only 9. So to find a minimum, we need to add 1 to it, right? So by solving that, it would become 82. So answer is 82. I think this is clear. If any doubts, please write in chat window. Because this is the last type of question we are discussing. Then after that, we'll be discussing quite different problems on pigeonhole principle. If it is clear, write in chat window. So the Siddhant question is, why we will consider the first year students? Actually, the question says we need to form a student club. So the student club can be formed by first year students also. Sorry, second year students also. This is second year students, this is the third year students, this is the fourth year students. So I said this is first year, but this is second year students. So actually, I said that this is first year, but this is actually second year. Sorry. So this is second year, third year, and this is final year. I think now it is clear, Siddhant. Okay. So let's discuss some questions on pigeonhole principle more. Next question is actually very interesting question and very simple question. Let's try to solve that question. These type of question which I am discussing is very simple, and this can be like, this will actually make you think, and you will be able to know that pigeonhole principle is so strong that these questions which seems to be like very challenging, but these questions are very simple. And if you see some MIT questions and some like Olympiads questions also, these type of questions which now I'm going to discuss is like there it would be asked. So, and these questions are very simple. We'll be solving in like less than 10 seconds. So let's get started with the first question. Question says 5 points were randomly selected. 5 points were randomly selected in an equilateral triangle with each side 1 unit. There will be at least 2 points. There will be at least 2 points of these 5 points such that the distance between them, so that the distance between the let's say it is 1/3, option 3, 1/4, option 4, it is 1/5. Question says 5 points were randomly selected in an equilateral triangle with each side equal to 1 unit. There will be at least 2 points of these 5 points such that the distance between the 2 points cannot exceed 4 options are given. So how to solve this? What answer we are going to get? If anybody has any idea, please write in chat window, or you can even speak and tell me the approach if you want. I think first question I will tell you, and the second question you can try, right? Okay. So question is like very simple actually. This question says we are having an equilateral triangle, first point, and from equilateral, let's say this is an equilateral triangle whose every side is 1, 1, 1. We are saying that we are picking up 5 points from this, and they're saying that if I pick up any points on this, let's say I'm picking up 1 point, let's say here, second point here, third point here, fourth point here, 5 point here. So the question says the distance between those 2 points cannot exceed what? Like the distance between the 2 points that you pick up from this equilateral triangle cannot exceed what? It is, first thing is, they're saying cannot exceed. It means that we need to find the maximum distance. I told you, whenever we find the word like minimum, maximum, like these kind of word, or indirectly they say exceed, then it simply means we need to apply PHP, right? Pigeonhole principle. So first thing is that, right? So it will give me the clear idea that we need to apply the pigeonhole principle. Now they are saying that in order to apply the pigeonhole principle, we need to have the pigeonholes, right? Pigeonhole must be there. So according to me, these 5 points are nothing but for me it is the pigeons. For me this is pigeons, right? Now always we remember one point, that in order to have 5 points, I need to divide up this into 4 points. Why? I told you in that theorem, if we need to find at least k plus 1 pigeons, right? I told you, and then k is nothing but we need to divide up. So k in this case is 5. So we need to divide up this into how many number of parts? 4 parts. So I'll divide up this into 4 parts. Let's say I'm dividing it into 4 parts like this way. Now it is very simple. Now we are having here, understand, average would be what? Average is nothing. 5 points is there, and pigeonholes is how much? 4. So 5/4. So average is nothing but how much? 1.25. So some pigeonhole would be consisting of two pigeons, मतलब 2 points, and some would be consisting of 2 points, and some would be consisting of 1 point. Very simple. Some would be consisting of two, and some would be consisting of one, right? So let's say we are picking up one. It means that from these four triangles, in any one of these triangles, we'll pick up 2 points. Let's say I'm picking up 2 points in this triangle. So first point would be this, let's say, and second point is this thing. Now you will ask me why you are picking up the 2 points here and here only. Why? Because the question says that we need to find the maximum distance. In order to find the maximum distance, I need to pick up the point in such a way that the distance should be maximum, right? So if I pick up 1 point here, 1 point here, then the distance would be how much? This is whole is half. So sorry, the whole is 1. So the half would be nothing but 1/2. So answer for this question is 1/2. So overall discussion simply says that I think I tried my best to explain this question. If you understood and if you have any doubts, please write in chat window. And if it is clear, please tell me in chat window also. If any doubts and if it is clear, please write in chat window. Ajinkya says clear. If it is clear, write in chat window. See guys, you need to tell me at least if it is clear or not, because you can even see all of these things in YouTube also. So I just want that you should be able to clear up every doubts here, okay? So you have to tell me. Anjali says, I'm not getting. Anjali says, I'm not getting after dividing the whole triangle. I'm not getting after dividing the whole triangle into 4 parts. Okay. See, after dividing into 4 parts, I find the average. Average is nothing but the total number of pigeons divided by the pigeonholes, which is nothing but 1.25. 1.25 simply gives us an idea. Some of these triangles would be consisting of at least 2 points, and some of these triangles would be consisting of at most 1, right? So it simply gives me an idea that from these 4 triangles, there will be one triangle which from that I picked up 2 points. Let's say that triangle is this triangle. So from this triangle, I picked up 2 points, and we need to find the maximum distance. So I pick up the point in such a way that the distance would be maximum. So the distance would be maximum only, and if I pick up the points which are farthest, so I pick up these 2 points, and after that, so the distance between these 2 points would be nothing but what? Half, right? Because this whole is 1. So I think that clears up your doubt. I think now it is clear, right? Okay, let's move over to the next part. Next question says 10 points were randomly 10 points were randomly selected. 10 points were randomly selected in a square. With each side 3 units. With each side 3 units. There will be at least 2 points out of those 10 points. Such that the distance between them can't exceed what? Question says 10 points were randomly selected in a square with each side 3 units. There will be at least 2 points out of those 10 points such that the distance between them cannot exceed what? Options are also there. The option one is 1. Let's say this is root 2. This is say 1 upon root 2. And let's say this is 3 by 2. I think this is entirely based upon the previous question. You can try. This is very simple. Ajinkya, your answer is not right. 1 is not the right answer. You can try again. You can try again. So, okay, let's start. Okay, so the first thing is again the same points. We are having 10 points that we need to pick up from a square. Let's say the square is like this way, whose each side is 3, 3, 3, right? So I need to pick up 10 points from this in such a way that the distance between those 2 points cannot exceed what? So the first thing is again we are having 10 points, right? So it simply gives us the idea that this is for us is nothing but the number of pigeons. For us, this is nothing but the number of pigeons. Okay. Okay. And also question says cannot exceed. This also gives us the indication that we need to apply the PHP here. Okay. So again, the next part is we are having 10 points is there. So we need to divide the whole of this into how many number of pigeonholes? 10 minus 1, which is 9 pigeonholes will be there. So let's divide up into 9 pigeonholes. So let's say I'm dividing the 9 pigeonholes like this. Okay. So now if you see what will be the average? Average would be how much? 10. Now understand 10 by 9. So it would be something. And so some pigeonhole would be consisting of it would be 1 point something. So some would be consisting of at least 2 pigeons. Sorry, in our points it is points. So some would be consisting of at least 2 points and some would be consisting of 1 point. So now let's say from this square I pick up 2 points. Now I need to find the maximum distance. I know 1 point, but I know maximum point would only be possible if I pick up 1 point here and second point here, right? Only this thing is I think Ajinkya you have done mistake because the maximum distance is nothing but the diagonal distance, right? So this is 1, this is 1. So the diagonal is nothing but what? Root 2. So answer is root 2. If any doubts, please write in chat window. If it is clear, please tell me that. If it is clear, write on chat window. Nidhi says clear. Ankit says clear. Anjali says clear. Okay. So let's discuss the last question over this concept, and then we can jump over to the most important concept, which is called as generating functions. Okay. So the last question says, seven points. 7 points were randomly selected. 7 points were randomly selected in a regular hexagon. With each side 1 unit. With each side 1 unit. There will be at least 2 points there will be at least 2 points such that the distance between them, so that the distance between them is less than equal to what? Again, based upon the previous concept, nothing is changed except for the figure. Nothing is changed except for the figure. Ajinkya, your answer is not right. Aman, your answer is right. One is right answer. Aman, your answer is right. One is right. Okay, let's start. So very simple it is. Now the question is saying less than equal to, which simply means exceeds, right? So exceeds simply means we need to apply PHP here. Okay. So first thing. Second is 7 points are there. It means that the number of pigeons for us is nothing but how much? 7 is going to be there. So we are having hexagon. So hexagon is 6 side benzene structure. So we are having 7 points. So we need to divide up in how many parts? Six equal parts. So let's divide up into 6 equal parts. 6 equal parts. Okay. So I think every side is like 1, 1, 1. Okay. So now the question is again the same part. We are having 7 points. We need to divide up. We are having the 6 number of pigeonholes. So some would be consisting of at least 2, and some would be consisting of at most 1, right? So some of these, like any one of this would be consisting of 2 points, right? So let's say we are having this triangle. So if we pick up 2 points, let's say we pick up 1 point there, 1 point there. So the distance between them is nothing but 1. Now you will ask me why you are picking up this thing. Why you are not picking this and this? Let's say even if you pick up this and this, again the point, this distance again is nothing but 1. Why? Because this is an equilateral triangle. An equilateral triangle sides is nothing but 1 only, right? So the answer for this question is 1. I think it is clear. If it is like any doubts, you can write in chat window. And if it is clear, you can also write on chat window. Okay. Now I will be talking about the generating function concept. So the next topic is generating functions. Okay. So the next topic is generating functions. So first thing is starting from the generating functions, I will tell you why we need to study about the generating functions, why it is important, first point. Because if I tell you that, then only it would be very easy. Because if I just start from very basics and tell you how to solve the questions, you'll be easily able to solve the questions, no problem with that. But first understand why do we need generating functions. Okay, so whenever we are having a huge data, and if you want to represent in a very compact form, let's say even if I say that I need to sum up all the numbers from, let's say, 1 from 100, then one thing is I can say 1 plus 2 plus 3 plus 4 so on up to 100. It will be very large also, and will not interested in that process. So one thing is what we can do is we can just combine it and use the summation notation, and then we can also do it, right? So first thing is we are saving the memory also, right? And even we will not be writing the so much. We'll be like writing a very compact form, which is very easy to understand also. It is same as saying writing a program in iterative or a recursive fashion. It will do the same task, but in case the recursive programs, it will be very small to write, right? So if you have like, I give you some motivation about the genetic functions. Now I think we start with the formal process of the genetic functions. Okay, so the first thing is, let's say we are having some sequence of real numbers. Let's say we are having a0, a1, a2, so on up to a of n be a sequence of real numbers. Then a function f of x, then a function f of x defined as, see how I'm writing it is very important, just understand it. 1 second. See how I'm writing it is very important. See, so I'm picking up the first term as it is. Now from the second term I'm multiplying with x, and the third term I'm multiplying with x square, third term I'm multiplying with x cube, and so on, and I'm multiplying a nth term with x nth, and so on. So this function is said to be called as a generating function. First thing, right? So this is said to be called as is the generating function of the sequence. Generating function of the sequence. I think this is right. Now I can also, like, this is very huge. I can also write it in a compact fashion also. So we can also write f of x is same as saying summation n going from 0 to, let's say, infinity, a of n into x of n, right? So this is the basic fundamental concept that we need to know from this concept of generating function. Now let's try to form some generating functions so that we could have a very basic understanding and then be able to solve many questions also. So let's start. Okay, so the first thing is, let's say, first question is, for the sequence C0, C1, C2, so on up to C of n, where C of k is nothing but the combination part, like nck. So it is nck. I'm writing in this fashion. Let's say nck only. Okay. So the question is, the genetic function for this is equal to what? So for the sequence C0, C1, C2, so on up to C of n, where C of k is equal to nck, the genetic function will be what? Again, let's say that the genetic function is represented by f of x. Let's say that it is going to be represented by f of x. Then what I'm saying is, if I'm writing here x, then what I will do, I will pick up the first term. Then I will pick up the second term, multiply with x. Then I will pick up the second, like the third term, multiplying with x square. I will pick up the next term, multiplying with x cube, and so on up to c of n, x of n, right? So one thing we know, this whole concept is nothing but actually it is a binomial expansion of 1 plus x whole power. So if you see, the generating function for this is nothing but 1 plus x whole power n. Why? Because this is the binomial expansion of this thing. So the generating function for this sequence is nothing but 1 plus x whole power n. If it is clear, write in chat window. If it is clear, please write in chat window. Anjali says yes. Nidhi says yes. Ankit says yes. See, I'm starting from very basics, then I will be coming on to the difficult questions also. So don't worry about that. But first we'll start from very, very basics, right? Okay. So the next question is, again, the next question is, now the sequence is, let's say we are having for the sequence, let's say the sequence is C0 minus C1, C2 minus C3, C4, and so on up to minus 1 power n C of n. Again, you have to tell me the generating function equal to what? Again, it is very simple. You can write in chat window if you know the answer. Yeah, I think you are right. 1 minus x whole power n. Okay. So again, it's very simple. Let's denote the genetic function by f of x. Pick up the first term, Then take the second term, multiply with x. Pick up the next term, multiply with x square. Pick up the next term, multiply with x cube, so on up to minus 1 power n c n x power n. Now, this is nothing but the binomial expansion of 1 minus x whole power n. So the answer for this question becomes 1 minus x whole power n. This is the answer. Simple, right? Okay. Let's jump over to the next part. Question number 3. It says that for the sequence 1, 1, 1, so on up to 1, n times, generating function equal to what? See, I'm starting from very basics, I'm telling you. So you have to bear with me. For the sequence 1, 1, 1, so on up to n, generating function equal to what? Anybody can try? Anybody can try and write in chat window if they want. It is very simple, right? Okay, just do it simple. So let's denote this genetic function with f of x. What is f of x? Write the first term, then pick up the next term, multiply with x. Pick up the next term, multiply with x square. Pick up the next term, multiply with x cube, and so on up to pick up this thing and write with x power n. So if you see here, it is nothing but 1 plus x square plus x cube, and so on up to x power n. It is nothing but what? It is GP. And the sum of the GP is nothing but 1 minus x power n divided by 1 minus x. So this becomes the answer. This becomes the answer for this part. So this will be x power n minus 1. See, the biggest mistake that anybody can do in this question is, here we can write x power n, but that is wrong. Why? Because it is saying 1, 1, 1 is going to appear n number of times, and I'm starting from x power 0. I'm starting from x power 0. So the last term would be x power n minus 1. So after summing up, it will simply become 1 minus x power n upon 1 minus x. Simple. So if it is clear, please write in chat window. If it is clear, write in chat window, please. Okay. Now let's modify a little bit and modify this question to, let's say, infinite times. Infinite times. Let's modify this and write this as infinite times. So this is question number 4. Okay. Again, the same. It will go up to infinite number of times. And we know the sum for the infinite number of times is nothing but 1 upon 1 minus x. So answer is 1 upon 1 minus x. Simple idea. Yeah, actually your answer is right. 1 upon 1 minus x. Simple. Now let's move over to the 5th question. Now, one thing you will simply ask me, sir, you always write directly. You remember, or you have mugged up something. How do you know that directly you write directly as c0 plus c1 of x plus c2 of x square and so on up to cn x power n? Directly you write as 1 plus x whole power n. And if it is minus, you directly write as 1 minus x whole power n. How do you know all of these expansions? I do not know these expansions, and you will be able to know from after doing some questions, and I will tell you many tricks also which you can use to get the answer. But one thing I'm telling you, in order to expand any binomial expansion, you need to learn this which I'm writing here. It is very important. You can note it down. So it simply says 1 minus, it is a generalized expansion. You will not find in books, I'm telling you. So generalized expansion, it says that 1 minus ax whole power minus k. 1 minus ax whole power minus k expansion is actually equal to summation. What happened to this? Summation n goes from 0 to infinity. N, just 1 second, sorry. So it is nothing but C n minus 1 plus k comma n a power n x power n. So it is very important to know, it says that in order to expand 1 minus ax whole power minus k, it is nothing but summation going from 0 to infinity c n minus 1 plus k and a power n x power n. Right? Now let's try to apply this in one or two questions. Right? So let's say the question number 5 is you need to expand, let's say 1 minus x whole power minus 2. You need to expand 1 minus x whole power minus 2. So let's apply this formula. In this question, if you see, a is nothing but 1, k is nothing but 2. So apply the formula. It says that n goes from 0 to infinity. C, n is as it is minus 1. K is 2, so you write it 2. N is n. A is 1, so I'm not writing here. A is 1. And x is x power n. N is nothing but n only. Okay. So what we get, n equal to 0, select our infinity. C, it is nothing but n plus 1 comma n x power n. So what is this? If you put up 0 here, what we get to this? So we get is n plus 1 c n x power n. Now this is nothing but, let's solve here. It is nothing but n plus 1 c n. Now what is this funda? This is same as saying n plus 1 c n plus n minus 1. Why? Because NCR is equal to NC n minus r. If you see n cancels, it becomes n plus 1 c1. And NC1 is nothing but how much? NC1 is equal to how much? N plus 1. So this is nothing but, this whole is nothing but n plus 1. So we can write here n 0 select infinity n plus 1 x power n. Simple, right? Now put up 0 here. If you put 0 here, it becomes x power n. Sorry, x power 0, which is nothing but 1. Now if you put 1 here, it will become 2. And if you put 1 here, it will become x. Now, if you put up 2 here, it will become 3. If you put 2 here, it will become this thing. Right? And if you can guess the next term also. If you put 3 here, it will become 4. It will become 3 and so on. So on. The last term would be how much? The last term, if you see here, it goes up to infinite. So it will go up to infinite. So this is the expansion of 1 minus x whole power minus 2. Now one thing is from this we can learn from now onwards is, Ajinkya, you are saying it's minus x whole power n. No, it is not minus x whole power n. It is x power n only. Why? Because here it is minus k, not k. Right? Okay. So one thing you can remember from this is that 1 minus x whole power minus k expansion is this thing, which is 1 plus 2x plus 3x squared, so on up to infinite. So how I'm directly write from this to this is very simple. See, what we need to just remember is 1 minus x whole power minus 2. What I can directly write is, write 1 as it is. Then see here, if minus minus is there, then we can directly write 2 into x. Then we can directly write 2 into x, because minus minus will form 1, right? So minus minus will form 1, sorry, plus, then 2 into x we can directly write it. Then we can increment the terms and the powers also. So it will become 3x squared, 4x cubed, so on up to infinite. So we do not even need to remember all this. We can do it in like very fast, right? Simple. So I think this is clear. If it is clear, write in chat window again. If it is clear, please write in chat window, because you won't find anywhere this concept, because this is like from practice. I'm telling you all this. If it is clear, write in chat window so that I can discuss more parts. Ankit says, please repeat the tricks. It is not a trick actually. So one thing is you can apply the formula and expand it like this, right? The next thing is, I'm writing here again. So the next thing, the thing which I said is, if I need to expand 1 minus x minus 2, then we can just copy 1 here. Then minus minus would become plus 2 into x. So we need to write up 2 into x directly. Then 2 plus 1, 3, x power 1, x power 2, 3 plus 1, 4, x power 2, x power 3, so on, up to infinite. So this is the expansion. Ankit, I think it is clear now. Okay, now let's expand one expansions again. The next is question number, I don't remember, 6 or 7. It is 1 minus x whole power minus 3. 1 minus x whole power minus 3. So one thing is, again I'm repeating here, we'll write directly now, I will not write it again. So just copy 1 directly, then minus minus would become plus 3 into x. Again, understand 3 plus 3, see how I'm writing, how will I increment is very important. In case of 2, I incremented by 1. Now in case of 3, the next term would be 6x square. Next term would be 10x to the power 3. And so on up to infinite. So how I'm writing here is very important. Here if you see 1, then I'm getting 2. So the difference is 2. Here the difference is 3. Here the difference is 4. So you can guess the next term would be 15x power 4 and so on. So these are not the tricks. These are nothing but the expansion of this thing only. So either you can use this to expand this, or you can directly write it also if you want. Clear, right? So next thing is, next expansion is, let's say, last question we try, 1 minus x whole power minus 4. Let's solve with this only, let's say. So a in this question is 1, k is equal to 4. Comparing we are doing. So a will become 1, k will become 4. Apply this formula, we get summation n going from 0 to infinite. C n is n minus 1 plus k, which is 4 comma n. A is 1 only, so I'm not writing here, x power n. So how much it will become? Let's solve this part here only. So it is nothing but n plus 3. So n plus 3 cn. So what is n plus 3 cn? It is same as saying n plus 3 cn. It is nothing but what? It is nothing but what? We are saying n plus 1, n plus 2, n plus 3 divided by 3 factorial. Right? So just put up this here. We get summation n going from 0 to infinity n so it is nothing but what I got n, sorry, I got n plus 1, n plus 2, n plus 3 by 6 into x power n. Summation going from n equal to 0 to infinite. Now we can put up the value and get the expansion. Till now, if it is clear, write in chat window so that we will be discussing questions on generating functions now. If it is clear, write in chat window, please. Okay, now let's discuss question. The question says, I think question number 10 or 9, I don't remember that. For generating function of the sequence, the generating function of the sequence 0, 1, 2, so on up to infinite equal to what? Question says the generating function of sequence 0, 1, 2, 3, so on up to infinite equal to what? Anybody can try and tell me the approach of solving this part? See, this is very simple, right? So let's solve simply. Let's say the generating function is f of x. Write the first term as it is. Now 1 into x, 2 into x square, 3 into x cube, so on up to infinite. So if you see here, if you take x is common from this term, it will become 1, or you can directly do it also if you want. It is nothing but 1 plus 2 into x plus 3 into x square, so on up to infinite. It is nothing but what? it is like, understand one more point here. Even if it doesn't do it like this way, you know one point. This is nothing but x plus 2x square plus 3x square. We have already discussed it. This is expansion of 1 minus x whole power minus 2. How do I directly write it? Because I know one thing. What is the one thing? Minus minus would become plus. Then 2 into x, this term would come up, right? So the expansion, if I take x common, then it would become like that way. If I take x common, it will become 1 plus 2 into x plus 3 into x squared, so on up to infinite. So this term expansion is nothing but 1 minus x whole power minus 2. So the overall answer will simply become x divided by 1 minus x whole power minus 2. If it is clear, write in chat window, please. If it is clear, write in chat window. So the final generating function for this question will become x divided by 1 minus x whole power minus 2. I think Nidhi is saying I cannot continue because there is no electricity at my home. Please let me know later if anyone has recorded. Anybody can record if you want for the further use or to share with your friends or something. Okay. So the final answer would become x upon 1 minus x whole power minus 2. Now, let's say I'm modifying this question a little bit. Now, actually, the fun becomes the fun comes actually in this part. Let's say I'm just squaring all the terms. Let's say I'm squaring all the terms. And now I need to find the generating function for this. Now I need to find the generating function for this. Again, the one thing that everybody will say that, sir, you can directly do it like this way, which is f of x 0 square. Again, the usual process, right? So 1 square into x and then again 2 into 2 square into x square and so on. So we'll be able to get this result, no problem at all. But one thing, one shortcut we can say is nothing but what? We know that this sequence is nothing but actually every term just gets squared, right? So one thing we've already found out that the generating function, if the sequence is 0, 1, 2, 3, so on up to infinite, the generating function for this we have already found it out. It becomes x into 1 minus x whole power minus 2. This thing we have already found it out, I guess, right? So one thing is there is a shortcut for finding the generating function for this thing. One way is the usual process that I discussed it, and another way is what we can do is, yeah, Ajinkya, you are right, we can differentiate the previous one, but again we need to multiply that with x, right? Because we take x as common also. So the basic approach for finding the generating function from this is the recursion part, right? So what we do is the generating function for this is, let's say it is f dash, let's say it is g of x. Then it would be nothing but x multiplied by the differentiation of f of x, where f of x is the generating function of the previous one, right? So g of x is equal to x multiplied by d upon d of x into f of x. Here I need to discuss the power of recursion. Why? Because we are having the generating function of f of x and we are multiplying that with x. So we are using the result which we have already found out previously to find the generating function of this sequence. So if somebody is interested in competitive programming also, they can use this funda in recursion process to calculate 0 power n, 1 power n, 2 power n, so on up to infinite also. So that becomes a very interesting question, right? So let's not switch from that. Let's come on to this again. So again, we need to just differentiate this function. So let's differentiate it. It is x upon 1 minus x whole square. So we apply the question rule to differentiate it, and after differentiating, I'm not differentiating it. Everybody knows how to differentiate it. So after differentiating it, I think it will become x plus 1 divided by 1 minus x whole cube. So after differentiating, we get this thing. Okay. So now we just need to multiply this with x. So the final answer will become So the final answer would become x multiplied by x plus 1 divided by 1 minus x whole cube. If it is clear, please write in chat window so that we can proceed over to the next question. If it is clear, write in chat window. Anjali says yes. Ankit says clear. Okay. So now again, I'm modifying a little bit again, because even if we try to solve in various ways and try to modify the question, then we learn a lot, right? So let's modify it and make it as cube. Every term is cube. Now think how we can do it. Every term is cube. Again, the same process we apply, right? Whatever answer we got, we just need to differentiate it and then multiply with x. We get the answer. One way is to do it in a usual process. Take this term, multiply with x, take this term, multiply with x square, and so on. Another solution would be take the generating function, which is this, differentiate it 2 times, and then multiply with x square. Another solution is take the generating function of x square wala and then differentiate it and then multiply with x, we get the result. I think you can do it. If you can do it, please write in chat window that this is clear. Okay, so let's jump over to the next questions. So I don't know the question number, but up now in this question, the question is actually little bit twisted. So you need to try if you want, right? So very simple, but we can try. Okay? So the question says the generating function of the sequence A0, A1, A2, so on up to A of n up to infinite, where A of n is equal to, where A of n is equal to n plus 1, n plus 2 is equal to what? Question says the generating function of the sequence A0, A1, A2, A3, so on up to infinite, where nth term is equal to n plus 1, n plus 2 is equal to what? Very simple. See, the first thing which students actually do is, when I solve this question, firstly also I did the same. So what the student will think that they pick up A0, multiply, then A0 plus A1 of x plus A2 of x square, and so on, usual process they do. But in this question, they are saying that the nth term is this. If you are having nth term as that, it simply means what? Actually, what we do, we just actually sum up all the terms, right? So what I do is, I just do only one thing, that the generating function, let's say, is f of x. What I need to do is, I need to add up all the terms and multiply with x, x square, x cube, so on up to x power n. So I take n plus 1, n plus 2, multiply with x power n, and I put the summation as n equal to 0 to infinite. So if you see, this is actually the same generating function that we get from this thing, but we do not need to do it, right? Why? Because the term is actually given to you. The term is actually given to you. So see, if you put 0 here, we get the first term. If you put 0 here, we get 2 into, like, the first term would be 2 only, right? The next term would be nothing but how much? If you put 1 here, it will become 2. 3 into 2 is 6, so 6 into x, and so on. So we get the generating function from this term which is given. Right now, only thing is, if I just like divide by 2 and multiply by 2 also, now everybody knows that this is nothing but the expansion of 1 minus x whole power minus 3, and the 2 is outside, so this becomes the answer. See, the answer is very simple. We are getting the answer in like less than 10 seconds only. Okay, so how I write 1 minus x whole power minus 3, I have already given you the generalized expansion. So we can use that to know that why this expansion is 1 minus x whole power minus 3. So overall answer becomes 2 into 1 minus x whole power minus 3. See, after every question you have to write in chat window at least that it is clear. Okay, so let's jump over to the next question. See, I'm not modifying much. Question says that now the general term is n plus 1. N into n plus 1. N into n plus 1. See, again the same thing is going to come into the picture. That is, again we do the same process. Let's say that it is f of x. What we do? We do n into n plus 1 into x power n. Do the summation from n equal to 0 to infinite. Again, what we can do is, let's say, see, this is not forming any expansion. If you see here, this is not forming any expansion. So let's say I'm replacing n with n plus 1. N with n plus 1 I'm replacing. So this would become, f of x would become simply n equal to, let's say this would become n plus 1 equal to 0 to infinite n plus 1 n plus 2 x power, if you see here, x power n plus 1 n plus 1 n plus 2 into x power n plus 1. Now I'm dividing by 2, I'm multiplying by 2 also. Now we can write x power n plus 1 as x power n into x also. See, x is actually the independent term. Why? Because the summation is for n and we are finding x, and x has no relation with n. So we can take this x outside the summation, so it becomes 2 into x. So finally we get 2 into x. See, n plus 1 equal to 0 to infinite is same as saying n equal to 0 to infinite. So this whole expansion we have already seen, this whole expansion is nothing but what? 1 minus x whole power minus 3. So this would become the answer. See, this is very clear. So the final answer would become 2 into x into 1 minus x whole power minus 3. If any doubts, please write in chat window. And if it is clear, write it also. Ajinkya says clear. Okay. So one thing is, let's modify a little bit and play with it. Let's say now I see this. These all questions are not having it. I'm just forming the question and doing it. Okay. So let's say I'm squaring this thing. Let's say a of n is this only, and the question says, do you need to find the genetic function of, let's say, a n square? Now for you, sir, every time we have to break this into this form. Yeah, of course, we have to break it in this form only, because why in this form only? It can be in any form, but it should be like the expansion of something. And how do we know that it will be expansion of something? That will come from practice and from that expansion that I gave you. Okay. So the next thing is, we need to find the genetic function of a of n whole square. So now everybody should know, to find the genetic function of a of n whole square, what we need to do, we need to take up this, differentiate it. After differentiating, we need to multiply with what? X. That would be the answer for our question, right? And let's say I need to find the genetic function of a cube. Then I need to take up this answer, differentiate it again, and multiply with x. So that would become the answer for this question. Now I think it is clear. Okay, so let's jump over to the next part. The next question says, question number 15, I guess. I don't know. Okay, so question says the genetic function of the sequence where same thing is a of n is equal to n plus 1, n plus 2, n plus 3 equal to what? Again, the same thing we do. We do the summation going from n equal to 0 to infinite, n plus 1, n plus 2, n plus 3 into x power n. Right? Now, let's divide by 6 and multiply with 6 also. Now we know one thing, that this whole expansion we have already discussed in the examples, that this is an expansion of 1 minus x whole power minus 4. So the final answer would become 6 upon 1 minus x whole power 4. So this is the answer for this question. Let's do the next question. Question number 16. It says the genetic function of 1 minus 2, 4 minus 8, so on up to minus 2 power n, so on up to infinite, equal to what? So now there is no German term which is given. So let us assume that the genetic function is f of x. So it would become 1 minus 2 into x plus 4 into x square minus 8 into x cube, so on up to minus 2 into power n into x power n, and so on up to infinite. Now, from this, if you see that we can write in a very compact form as n equal to, let's say 0 to infinite, I can write it as minus 2 power n into x power n. I can write this whole expansion as summation going from 0 to infinite minus 2 power n x power n. Now, this whole expansion, if we compare with our journal theorem, journal expansion theorem, then we get as this whole is nothing but 1 upon 1 plus 2 into x, which is actually nothing but 1 plus 2 into x whole power minus 1. We can expand it, we get the same result as this, because here a will be nothing but minus 2 and k will be nothing but 1. So we can expand it to get the result as this thing. So this is the next question. Next part. Next is very important concept, to find number of non-negative integral solutions. Number of non-negative integral solutions for the equation x1 plus x2 plus x3 so on up to xn is equal to k. Okay, so question says what? We need to find the number of non-negative integral solutions for the equation of x1 plus x2 plus x3 so on up to xn is equal to k. First of all, what is the actual meaning of this? Actually, let's say that we are having, let's say, x1 plus x2, and we are having, let's say, it is equal to 2. See, the non-negative integral solution means it will be greater than or equal to 0. Okay, so we need to find all those solutions for which this equation will be satisfied. So the first thing would be 0, 2 I can take, 2, 0 I can take, 1, 1 I can take. So no other solution would be possible for this. So for this part, the number of the non-negative integral solution for this equation would be 3, right? So we need to find in a generalized fashion that what is the number of the non-negative integral solution for x1 plus x2 plus x3 so on up to xn equal to k. Okay, so we will use the concept of genetic function here. Let the genetic function be f of x is equal to, again the same thing I will do. I will say that the genetic function for all of these things would be nothing but the generating function of x1 generating function of x2, generating function of x3, and so on up to generating function of, let's say, this is f1, this is f2, this is f3, and this is let us say that this is f of n x. Let's say that. Okay, so but what we're saying is we need to find the generating function of these things. So we are saying that we are pick up the generating function due to this thing, this thing, this thing, this thing, this thing, this thing. Now A would only be formed due to the collaboration of all of these things. So we want everything. So we are multiplying all of the generating functions, right? Okay. So now we are saying is nothing but what? Now we know one thing, but we know one thing here, that f1 of x would be what? It is nothing but it is saying what? F1 of x is saying either I will not give anything, either I will not give anything, x power 0. Either I will give, let's say, either I will give 1, or either I will give 2, either I will give 3, or I can go anything up to infinite, right? So this is nothing but expansion of 1 minus x whole power minus k, right? Wanted to find the coefficient of x power k in the expansion of this f of x. See, I already told you in session 2, I guess, in order to find the number of non-integral solution, we just need to find the coefficient of x power k in the expansion of f of x, right? Where f of x is the product of all of the generating functions, and f1 of x would be this thing. So this whole problem is to find the coefficient of, this would be clear with questions. So we need to find the coefficient of x power k in the expansion of one minus x whole power. We already know one thing, that 1 minus x whole power minus n expansion is nothing but summation going from 0 to infinite n minus 1 plus k c k x power k. See, what I'm trying to write is what? Say, I've already told you just now that that theorem part, 1 minus ax whole power minus k expansion. So here I'm writing the expansion of 1 minus x whole power minus k. Sorry, minus n. In our case, k is equal to n. A is equal to 1. So the expansion would simply becomes n minus 1 plus k comma n x power k. Simple, right? So here I need to find the coefficient of x power k. So if you see here, the coefficient of x power k is nothing but what? This thing. So I will use a generalized notation for this. The generalized notation for this is let us say v of n comma k. So now I will not write this n minus 1 plus k comma k. We'll write v of n comma k. We'll write v comma v of n comma k. So I think now it is clear, right? Okay. So let's solve one question over this, then it will be very clear. Okay. So the first thing that we discussed here is, let's say, suppose we need to find, see, the question says the coefficient of x power 20 in the expansion of x की power 3. One second. So in the expansion of x की power 3 plus x power 4 plus x power 5, so on up to infinite whole power 5 is equal to what? Question says the coefficient of x power 20 in the expansion of x power 3 plus x power 4 plus x power 5, so on up to infinity की power 5 is equal to what? Similar question has been asked directly in GATE, I think 2016 exam. See, I think in session number, I guess, 2, I told you how to solve these kind of questions in less than 10 seconds only, right? How we can do it, I also told you. We can pick up x to the power 3 as common, then x to the power 15 will come out, then x to the power 15 will come out. We need to find 20. So from the remaining, we just need to find the coefficient of x to the power 5. Then this whole expansion is 1 upon 1 minus x whole power minus 1, which is 1 minus x whole power minus 1. So we can directly use it to find the coefficient of x to the power 5. I think I'm doing it in fly, but yeah, you can do it. That way is also right, but I will tell you the way of solving with the help of generating functions. Okay, so let's solve with the help of generating function this answer. So let's again take x to the power 3 as common. So if I take x to the power 3 as common, x to the power 15 will come out, and this would be 1 plus x square, so on up to infinity to the power 5. Okay, so x to the power 15 would come out. Now we know that this whole is nothing but 1 upon 1 minus x whole power 5. I think that is clear. I can also write it as x to the power 15 into 1 minus x whole power minus 5. We can also write 1 minus x whole power minus 5. Now, one thing we know very clearly, I know, that is 1 minus ax whole power minus k expansion. What is that? That expansion I already told you. N going from 0 to infinity, n minus 1 plus k, comma n, a power n, x power n. Okay? So we got n minus 1 plus k, comma n, a power n, x power n. Simple idea. So what we are saying is 1 minus x. Let us say we need to find 1 minus x whole power minus 5. So what is 1 minus x whole power minus 5? It would be nothing but n going from 0 to infinite. See n minus 1 k. K is nothing but 5 in our case, right? So like 5 comma n. A is nothing but 1, so I'm not writing, x power n. So what we got? We got n going from 0 to infinite, c of n plus 4, comma n, comma x power n. I think this is right. So we just need to find, now see here, what I got is this thing. I need to find x to the power 20. X to the power 15 I already got. So from the remaining, I just need to find the coefficient of x to the power 5. I need to find the coefficient of x to the power 5. So here I want x to the power 5. So if I got x to the power 5, it simply means n should be nothing but 5. So I can just put 5 here and I got the result. So we got 5 plus 4, which is 9, comma 5. So the answer is 9C5. 9C5 is 126. Answer becomes 126. I think it is very clear. If it is clear, write in chat window, please. If it is clear, write on chat window. See, again, let's modify a little bit. Let's say we need to find the coefficient of x to the power 25. See, we need to find 25. We already got 15. We just need to find how much? Coefficient of x to the power 10. We need to find the coefficient of x to the power 10. So here, n would be nothing but 10. So we can just put n equal to 10. So 10 plus 4 will become 14. This will become 10. 14C10, which is 14C4. We can solve 14C4 to get the coefficient of x to the power 20. So we can solve any equation with the help of generating function concept also, right? Okay. One question based upon the similar concept I'm giving you, and I will give you some head start, then you can try it also. Okay. So number of non-negative integral solution integral solution to the equation x1 plus x2 plus x3 so on up to x power 5 equal to 15, where x1 would be greater than equal to 1 less than equal to 5, and x2 would be greater than equal to 2 less than equal to 5, x3, x4 and x5 all of them would be greater than equal to 2. Question says number of the non-negative integral solution to the equation x1 plus x2 plus x3 so on up to x5 is equal to 15, where x1 is between 1 to 5, x2 is between 2 to 5, and x3, x4, x5 is greater than equal to 2. See how to solve this first time. Very simple. See, x1, I know one thing, that solving this is actually same as saying, let us say that the genetic function is f of x. Then I know that actually the solution for this question is the product of the genetic function because of x1 into the genetic function due to x2 into the genetic function due to x3. Similarly for x4 and x5. Right. Now we know that the genetic function because of x1 would be what? They are saying that x1 would be between 1 to 5. So its genetic function x could be either 1 or x could be either 2 or x could be either 3 also. X could be either 3 also, it could be 4 also, or it could be 5 also. Similarly, for this x2, it will be from 2 to 5. So it will be x2, it could be either x3, so on up to x power 5. Similarly, if you see for x3, x4 and x5, they are greater than equal to 2. They are greater than equal to 2. So if they are greater than equal to 2, it means that they can go up to from 2 to 5, right? So they can go up to 2 to 5 or from 2 to infinite. It will be from 2 to infinite. Why? Because they are not giving any restriction. They are saying it will be greater than equal to 2. If it is greater than equal to 2, they can add up to infinite also. Although we cannot take infinite, but definitely they can take up infinite value also. So because nothing is mentioned, right? So we say that x2, x3, so on up to infinite. This is for f3, this is for f3. So f4, f5, so we cube it, right? Now, again, we just need to solve it. Very simply, we solve it. We take we take x common from this. It will become 1 plus x square plus x cube plus x power 4. From this, we can take x square common. If I take x square common, it will become x3. We got 1 plus x square. See, 2, 3, 4, 5. 4 terms are there. So 1, 2, 3, and 1 term more, we got x3. See, again, from this, if you see, we can take x square again common. If I take x square common, cube is also there. So we got x square ka cube. And inside we get 1 plus x square, which is nothing but 1 upon 1 minus x whole cube. Right? So what we got? X power 3 here, x power 6 here. So 6 plus 3, 9. So we got x power 9, and rest term, see, this is a GP. So what we got from here, 1 minus 1. We got 1 minus x power 5 divided by 1 minus x. Right? Similarly, here I can write 1 minus x power 4. Just 1 second. Right? So we can write it as 1 minus x power 4 divided by 1 minus x. And again, this is nothing but 1 minus x whole power minus 3. Right? So if you see here, 1 minus x, 1 minus x, 1 minus x whole square. So this whole expansion would simply become x power 9, 1 minus x power 5 into 1 minus x power 4. This would become x power, this is minus 3. this is minus, and it is 1 minus x minus 2. So it will become minus 5, right? So it will become minus 5. Now, one thing is we need to find the coefficient of x to the power 15 here, and we already got x to the power 9. So now from this part, we need to find the coefficient of x to the power 6. We need to find the coefficient of x to the power 6. Now, how do we find the coefficient of x to the power 6? We know we can just multiply this, and then we can accordingly take com. So from these two brackets, I can take one thing common, and then I can multiply to get the coefficient of x to the power 6 accordingly. So now after this, at least you can try to solve the part. I'm telling you the answer for this. The answer for this will become 200. 200 is the answer. You can try, right? Okay. So the last question now we'll be discussing. See, as I told you, I started from very basics, and now I'm discussing like very good questions also. So this is the agenda only. I start from very basics and go till very advanced only. Okay. So the last question is also very not easy, at least, but it is very interesting. Okay. So the last question goes like this. Last question. Question last. Okay. Question says how many ways we can choose a committee. We can choose a committee of 9 members. We can choose a committee of 9 members from 9 political parties. From 9 political parties, so that no party has absolute majority. Absolute majority in the committee. This is the last question and the most interesting question. Question says how many ways we can choose a committee of 9 members from 9 political parties so that no party has an absolute majority in the committee. If anybody has some approach, they can speak and tell to everyone. See, how actually I thought about this question is like this way. See, the question says how many ways we can choose a committee of 9 members from 9 political parties, right? Absolute majority is nobody more than 5. Uh, Actually, you are right in one sense, but not more than 5 is actually little bit wrong, right? How I thought is like, listen here. So the question says 9 members from 9 political parties. Okay, so we need to form. First thing is we need to form how many parties. We need to form. First of all, we need to decide how many parties do we form. Do we need to form, right? So first we need to form is 3 parties, right? So we want to find the number of non-negative integral solutions to x1 plus x2 plus x3 is equal to 9. Now, suppose let's say that this is 1, this is 1, this is 2, and this is 3. The total is 9. And there's also one condition here that there is no party has absolute majority. Majority will no party will have a majority means what? If every party, is between 1 and 4, then there will not be majority. If every party is between 1 to 4, there will not be any majority in this case. Why? Because if let's say this is 4, this is 4, and let us say that this is definitely this is 8, then this would be 1. But this is not a majority because these two are same. But as Ajinkya said, it is not more than 5. It can be 5. Let's say if I take 5 and if I take 4 here, then this will become 0. Then this would be majority. So it cannot be 5, right? And you are saying nobody could be more than 5. More than 5 means it could be 5 also, right? So 5 is not possible. So only thing is between 1 to 4, right? So this x, now again, we just need to find the coefficient of x to the power 9 in the generating function, which is due to x1, due to x2, and due to x3, right? Now what is f of x1? It says that either x could be 1, or either x could be 2, or it could be 3, or it could be 4. And similarly for this and this, so I'm cubing it. So I'm cubing it, right? So now we can take x to the power 3 as common. So if I take x to the power 3 as common, it would become 1 plus x square plus x cube whole power 3, right? So now we can write it as x power 3. This is same as saying 1 minus x power 4 upon 1 minus x whole power 3. I think this is clear, right? So let's solve it further. Let's solve it further now. So I'm writing x cube as it is. Now 1 minus x power 4 whole power cube. Expansion would be nothing but we can expand it with our generalized theorem. It would become, I think, 1 minus 3x to the power 4. 1 minus 3x to the power 4 plus 3x to the power 8 minus x power 12. Minus x power 12, and the remaining is 1 minus x whole power minus 3. 1 minus x whole power minus 3. Now what I can do is I can multiply this with x cube every term. We got x power 3 minus 3x power 7 plus 3x power 11 minus x power 15, and we got 1 minus x power minus of 3. We got 1 minus x power minus 3. No problem. Now actually we need to find the coefficient of x to the power 9. We need to find, don't forget, we need to find the coefficient of x to the power 9. That would be our answer. We need to find the coefficient of x to the power 9. That would be the required answer. Okay. So how we actually thought of is nothing but let's generalize this by first thing. So first thing is from this, if you see the expansion of 1 minus x whole power minus 3 with the theorem that we discussed was nothing but what? It was summation n going from 0 to infinite. It will be n plus 1, n plus 2 by 2 x power n, right? Okay, so it would be like this, and I'm replacing this with x power 3 minus 3x power 7 plus 3x power 11 minus x power 15, right? So one thing is we need to find the coefficient of x to the power 9. Fine. So if I'm having x power 3 here, then if I multiply with this thing, it means from here I want the coefficient of x to the power 6. So from this I will put n equal to 6. I will get something, right? Minus 3. Now here I'm having x power 7. From here I want x power 2 coefficient, so that we'll get x power 9. So here I will put n equal to 2, right? I will put n equal to 2. I will put n equal to 2 here, right? But here I'm having x power 11. So we cannot take anything here. Why? Because it is already x power 11. So we will not get anything more terms. Why? Because we want x power 9 and we are having x power 11. So we cannot get negative term here. Why? Because n goes from 0 to infinite. So we can just put n equal to 6, then minus 3 times of put n equal to 2 here. The answer, the answer what we got is, I think, answer 10. So the 10 would be the final answer for this problem. I think this is an exhaustive session. I think I don't know how many of you are attending the session, but I think this will be very useful. I tried my best to explain you the concept from very basics to very advanced level, and I think you liked it. And thanks for attending. And if you have any suggestions and some queries, you can like post in the group that we're having. And also please post the reviews of this session. How do you like it? And I mean, what is your opinion about all of these? Okay, thank you.